let me show you the code to do the same thing in numpy. And then once we're familiar with, once we get the syntax of numpy, I'll switch over to talk about types of matrices. And then we're ready to talk about array decomposition. So I'm going to open a new notebook, matrix operations. IPY in B. So now what I need to do is go back up here and do Gaussian elimination, but with numpy. So what I'm going to first do is import numpy. Import numpy as NP. And then I'm going to use S to represent my system. Chuba, great question. What VS Code plugin are you using? It's called Jupyter. So if you want to do Jupyter Notebook, by the way, I recommend this versus installing Jupyter Notebook separately. If you click on the extension icon, these 4 boxes, search for Jupyter, and all you need to do is click install, restart VS Code, and you're good to go. Now, the reason I have to wait a while for Notebook to open up is because I have different Python versions. I should uninstall them. But otherwise, for you, should be straightforward. I've attached instructions on the dashboard for VS Code. So go through the instructions and you can have the same setup. Okay, so I'm going to have S stand for my system of inequalities here. So we have 2 rows with 100, 100, and 3000. Again, I'm going to leave out the 10 to the power 4 part. And this is 200, 100, 4000. Okay, so, and of course, I'm going to turn this into a numpy array because I want to perform matrix operations using numpy. Okay, so let's begin. Now, the first thing I did was swap row 2 and row 1. I'm just going to do that up here. I'm just going to swap them around like so. Okay. Now, if I want to subtract row 2 from row 1, I would do it this way. So we have row, and of course, we have to remember that we count from 0 in programming. So if I want to say the first row, I would have to put in 0. And if I want to say row 2, 2 minus 1, that's row 1. Okay. So if I want to subtract these two, I'll come back to the difference method. But yeah, if you want to subtract the second row from the first row, so subtract the second row from the first row, we type in the first row minus second row, and then it will subtract the second row from the first row. And then if I want to replace the first row, I'm going to go S of 0 equals, well, that difference. And to see the result, I'm going to simply print S. So let me run this again. If I print S, you can see we have done just that. 100, 0, 1000, 100, 1000. Okay, and I can continue this way. So right now I need to subtract row 1 from row 2 and then plug it into row 2. Okay, so that's this was supposed to be R underscore 2. R underscore 2. Just be careful here. Okay. So this, I'm just going to copy this bit. So I'm going to subtract row 1 from row 2. Now, addition, of course, in Python, it has 3 applications. You can use it to add 2 numeric data types, so int and float. You can use it to concatenate 2 strings together. You can use it to merge 2 lists together. But I'm just trying to make this look as, I'm trying to make the Python code look as much, to make it as close to what we see in the Markdown file, in the math. So here I want to subtract the second row from the first row and then replace the second row. And there we have it. And then you get the idea, right? Then we would multiply the first row by 1/100 and until we get to this point, until we get x and y. Okay. So I won't finish this part. You can do this on your own, but I hope you get the idea now. So what I'm going to do from this point onwards is show you what inverse matrix identity matrices do to any square matrix, and then we can see its output every step of the way.